Hi guys, this is Mr. Urrego, and today we're gonna solve some sum and difference identities. Actually, we're gonna use these identities for some cosine and sine functions. All right, so let's start. So we have our first one. The question here is the following: the sum is difference formula to simplify to a single trig function. Okay, find the exact value of the following. Okay, if possible, but right now it's possible because that's the idea. Okay, so we have cosine of 50 times cosine of 10 minus sine of 50 times sine of 10. So according to the previous formulas, this is a cosine function. Okay, so I'm going to bring my function right there, my identity. So cosine of the sum is equal to cosine of the first angle times the cosine of the second angle minus sine of the first times sine of the second one. So I'm going to use this identity to bring this into cosine of one angle plus another angle. Let me say that again. What are my two angles? My two angles are, let me get a pencil, here we go, blue, red, let's use red. My first angle is 50 degrees. My second angle is 10 degrees. Because I have cosine, cosine, then this belongs to a sum of a cosine. Now, how do we know this is going to be a sum or a difference? It depends on this. When in my identity I have a minus, then this is going to belong to a sum because my cosines will flip the sign. And my two angles are 50 and 10. So the idea is to identify the angles. To identify what function, if it's a sum or a difference. Again, the cosine will have cosine, cosine at the beginning. And then the sine will be the opposite. If you have a minus in between the identity, then my here will be a difference. And here, then, I have cosine of 50 plus 10, which is 50 plus 10 is 60. And then cosine of 60, we go back to our triangle, right, or to a unit circle. Cosine of 60 is going to give me 1/2. And that's the idea, all right? Condense and find the answer. Let's do one more. Okay, now, let's try this number 3 that I have here. So number 3, I have sine of 5 pi over 12, cosine of pi over 12, plus cosine 5 pi over 12, plus sine pi over 12. My first angle is 5 pi over 12. I can identify the two angles. And my second angle is pi over 12. All right. Now I have sine, cosine. Remember, my cosine identity is cosine, cosine. Here I have sine, cosine. That means this belongs to a sum or a difference of sines. Okay? How do we know it's going to be a sum or a difference? Here we go. My sine will remain. If in the identity I have a positive, then it will be a sum of the two angles. If the identity has a negative, then it will be a difference of the two angles. Right now my identity has a plus. Therefore, I know it's going to be a sum of two angles. What angles? Right in front of the sine, which is 5 pi over 12. And the second angle is in front of your cosine. Or same thing here. And again, because it's sine, cosine, then is my sine. So it's a sum of the sine. So that'll be my first step. Identify which one am I using. I just identified that I'm going to use the first one. Got it. Next, I identified that it's going to be, this is the condensing of this identity. Okay. And now what happens here is the following. Here in the inside, I have 5 pi over 12. 5 pi over 12 plus pi over 12. And 5 plus 1 gives me 6 pi over 12. And that's what I have here. But if I reduce 6 over 12, that's the same as 1/2. 1/2. And sine of pi over 2, according to my unit circle, my sine will be 1. So my final answer is 1. So I am condensing. I identify the sum of the sines, and then I add the two angles, and then I find my final answer. The sine of that angle is 1. Okay? Now let's go the other way. All right? Instead of identifying this, now let's use the identities to solve for an angle. Let me explain. So let's have, we have cosine of 75 degrees. Okay? Now, do I have that on my unit circle? Remember 30, 45, 60? No, I don't have that on my unit circle. Unit circle 30, 45, 60, and multiples of this. Okay? And then I have my quadrant angles, which is 0, 90, 180, and 270. All right? Or any multiples. 120, 135 is related to 45, 150 is related to 30, and so on and so forth. Okay? I'm going to link a video about the unit circle underneath. I explain the whole thing. An easy way how to understand and learn the unit circle, because the only thing that you need to learn is the first quadrant. Okay? I'll explain. So let's go back to this problem. We have cosine of 75 degrees. Do I have 75 degrees here? No, I don't. That means I have to use my sum of difference of cosines to make up for 75 degrees. So I can make up 75 degrees many ways. I can have 30 and 45. I can say that 45 and 30 is 75. I can also have a difference. Let me see, 75. I can make 75 out of 120 minus 45. So I can use a difference identity for my cosines to find this. So long story short is the whole idea is to make this angle with the sum or difference of two angles that I know on my unit circle. All right? In our case, we're going to use 45 and 30. Okay. What is my identity? So let me bring my identity. So cosine of an angle plus another angle, which is, in this case, this is going to be 45, and the second angle is going to be 30, okay, is the same as, look at this, cosine, cosine, change the sign because this is positive, it goes negative, and then sine, sine. Cosine, cosine, cosine of my first angle times cosine of my second angle, minus sine, sine, the same order. 45 and 30. So I'm applying this identity. Cosine of 45 times cosine of 30 minus sine of 45 sine of 30. I'm applying that identity. Now what? Here we go. Now we got to go back to my unit circle. So let me bring my unit circle. I'm showing my unit circle, but again, that's not the idea. The idea is to remember all these values or make the connections with the 30, 60, 90. 30, 60, 90 triangle. Opposite to the 30 is 1/2. Opposite to the 60 is square root of 3 over 2. Okay? So I explained that on the, I'll put the link underneath. So I'll make all the connections. Let's go. Cosine of 45. 45. Here's my 45. My cosine is the x value, which is square root 2 over 2. So this is my cosine. My sine is the second value. Cosine of 30, let's come to 30. Cosine is the first value, so square root 3 over 2. So I'm multiplying those two. Minus sine of 45. 45, my cosine and my sine are the same. So sine is square root 2 over 2 times sine of 30. Go to 30. Sine is my second. This is the x value, which is cosine. This is the y value, which is sine. Sine of 30 is 1/2. And I got my values from my unit circle. Okay, this we need to know. So hopefully you got to study, you got to know those values. Let's put those values underneath, organize. Okay, I'm plugging those values. And I have this. So square root 2 over 2, square root 3 over 2, square root 2 over 2, and 1/2. Now what? I got to multiply those fractions. Top with top, bottom with bottom, top with top, bottom with bottom. Square root 2 times square root 3 is 2 times 3 is 6. And the bottom is 2 times 2, which is 4. Minus, same thing on this side. Anything times 1 is the same thing. And 2 times 2 is 4. And now let's put this together because they have the same denominator. I keep the denominator and I just combine the top. Remember, they have different radicands, which is the number in the inside. Therefore, you cannot combine them. So you have to write them both together. And this is my final answer. So cosine of 75 is this. All right? So that's where we use the sum or difference of those angles. Let's do one more. Now we have sine of 285. Okay, 285. What can we do 285? Do we have 285 here? No, we don't have 285 as an angle, but we can make 285. We can make 285 out of, let's say, 240 plus 45. We can make 285 out of, let's say, 225 and 60. What about difference? We can make 285 out of, let's say, 330 minus 45. So we have different combinations. Any of them will work, okay? Any of them, all right? And the idea is to see which one we're going to use. And I'm using the unit circle to find those angles. Again, you need to know those multiples. All right, let's go. So we're going to use 225 and 60. It's a sine, so let me bring the sine. So sine of 225 plus 60, my identity is sine cosine, sine of the first angle times cosine of the second one, plus the sine will use the same sign. If it's a sum, then it will be a sum on my identity. Okay? My first part is sine of the first angle times cosine of the second one. Sine of the first times cosine of the second one. So sine of the first times cosine of the second one, which is 60. Same sign. Okay? And now what I do is I flip the sine for cosine, and I flip the cosine for sine. All right, and I go from there. Sine 225 cosine of 60, cosine 225 times sine of 60. And now I'm going to solve this. Again, you should know this, if not, unit circle. All right, sine of 225. 225 is in quarter 3. All right, it's 180 plus 45, quarter 3. So my sine and cosine are going to be negative. This is related to a 45-degree angle. Any 45-degree angle is square root over 2. My sine in Q3 is negative, therefore this is negative. Okay, next, cosine of 60. Cosine of 60, here's 60. Cosine is the first value, which is 1/2. Plus, cosine of 225, again, is related to the 45-degree angle, so it's square root over 2. And because it's in Q3, my cosine is negative. Yeah, my PowerPoint got cut right there. Sine of 60. 60 is the y value, which is square root 3 over 2. Once I have that, just bring them down, same thing. And now multiply top with top, bottom with bottom. All right, so the hard part is over. And the top is going to give me square root 2, negative over 4, and the other side is going to give me a negative 6 over 4. Put them together, and that's it. Right? Let's try the last one. Let's squeeze the last problem. So let's say that I give you something in radians, not in degrees. I would suggest to make it easier, turn this into degrees. So what do I do that? I turn that into degrees. That means I have to multiply times 180 over pi. This is your conversion unit. 180 over pi. The pi is going to cancel out. And then I do 13 times 180, which is 2340. And then I do 12 times 1, which is going to give me 12. I divide it and I get 195. So my angle is 195 in degrees. I forgot to put the degrees right there. So cosine of this is the same as cosine of 195. How can I make 195? Here's the question. So, oh, come on. Okay. I was supposed to bring the unit circle. So 195 is the same as 225 minus 30. All right. Here comes my unit circle. Okay. 225 minus 30. Cosine, I got my identity on the bottom. Because the cosine is a negative, remember, it flips. So my identity is going to be positive, and it's cosine, cosine, sine, sine. So it's going to give me cosine 225 times cosine of 30 plus sine of 225 sine of 30. All right, so let's plug those in. Unit circle, and now from now on it's the same thing. So that was the idea. And now from there, you just bring the unit circle and you find the values. Okay? So the idea was to show you this, guys. Please like the video, subscribe to the channel, and I'll